All right, hey everybody. Today is probably one of the most important concepts in statistics of all. If you understand something, you're definitely going to want to have a very clear understanding of standard deviation. So I got a couple things here real quick. Sx is the symbol for standard deviation that we're going to use for now. It's equal to the square root of the sum of each observation minus the mean squared, and then divided by the number of observations minus 1. And then when we're talking about describing a distribution, remember we had shape, outliers, center, and then spread variability. The standard deviation is a measure of variability. For a definition with standard deviation, you could say it is the typical distance of values in a distribution to the mean. On average, essentially, how far away are our observations to the data set's mean? Okay, so I randomly selected 3 responses from the question you had on your stats survey with the number of siblings. So this person had 1 sibling, this person had 3 siblings, and this person had 5 siblings. And again, so our number of observations is 3, and each one of these is an individual X value, an individual observation. The formula looks a little bit, like confusing, but it's really not so bad. So what we're going to try to do in this video is calculate the standard deviation and then just have a really a clearer understanding of what it means and how to interpret it in context. Okay, so let's calculate the standard deviation of the number of siblings in this sample size of 3. The easiest way to do it is to get a table going. So we are going to list, again, each observation, X sub I, each observation. Then we will list the mean, and then we will find each observation's distance to the mean. Okay. Again, I know it seems like kind of confusing, but we'll work through it. It'll be fine. And then once we have the distance from the observation to the mean, we will find the square of those values. And I'll explain why we're squaring here in just a bit. Okay, so each observation, we had an observation of 1, of 3, and of 5. We need this. We need to know what the average is. What's the mean of this data set? And again, the mean's super easy to find. We just need to add up each individual value. So 1 plus 3 plus 5. Then divide by the number of observations, which again was 3. So 1 plus 4, or 1 plus 3 is 4, 4 plus 5 is 9. 9 divided by 3 is 3. Okay, so our mean is again 3. Okay, so for this column, we're working in this part of our formula. We're doing 1 minus 3, which is negative 2. 3 minus 3, which is 0. 5 minus 3, which is positive 2. Okay, so I never finished this up. We're supposed to be squaring right here. Why we're squaring is important. If we were trying to calculate the average distance to this mean, and I just found the distance here just by subtracting using this little expression, and I added all these things up, I would get 0, and then 0 divided by 3 is 0, which would indicate that we have a standard deviation of 0, which is just not true. We know there's some distance here to our mean of 3. So to get around these negative values canceling out with their positive counterparts, that is why we're squaring. Okay, we want to get rid of the negative values, which are canceling out some of these positive values, and that leads to a standard deviation again of 0, which is not true. So hey, if I square these values then, I've got negative 2 squared for positive 4. 0 squared is just 0. 2 squared is also 4. Okay, so now that we have this part done, we just need to find the sum of that. So the sum of this column, or maybe I can, I'll just write it over here. The sum of each observation minus the mean squared. If I just add this column, we get 8. Okay, so now that we have this part tackled, the rest is going to be pretty easy. So the sample standard deviation for number of siblings in our class, let me go down here. Sample standard deviation then is equal to the square root of. So I'm just going to replace all of this the sum of each observation minus the mean squared. I have that. It's literally equal to 8. So 8 divided by the number of observations minus 1. So that is going to be 3 minus 1, which is just 2. Okay, and then let's work on simplifying this a little. So the sample standard deviation then is the square root of 4, which is approximately, well, it's not approximate, it is exactly 2. What am I thinking? Square root of 4 is 2. That's it. So our sample standard deviation here again is 2. Gosh, now let's just interpret this real quick in context. On average, so again, to interpret, you're always going to want to add context. On average, the number of siblings, varies by 2. On average, the number of siblings varies by, on average, the number of siblings varies by 2 from the mean of 3. Okay, so I'll make another video where we go through another example and we interpret something else. For now though, as long as you know this, the standard deviation, it's a crazy cool name for a very simple concept. The standard deviation, again, is just the typical distance to the mean, the average distance to the mean. Again, it just measures variability. And here's how you interpret it, right? Just the number of siblings in this case, because that's just adding some context to our solution. So we're going to play this little game real quick. I got it down here on the bottom. I have 3 different dot plots for 3 different data sets. And just for convenience, I marked the sample mean on each dot plot. So what I want you to do is just take a guess here. What distribution do you think has the highest standard deviation? Which one do you think is kind of in the middle? And then which one would have the lowest standard deviation? Again, just try it on your own just to kind of think about it. But if we're thinking of standard deviation as distance to the mean, the data set that has the most observations furthest away from the mean is this one. It's got what, 1, 2, 3, 4, 5 observations way over here, another 5 observations way over here, and it doesn't have a single observation that falls directly on top of the mean. So again, this would have the highest, standard deviation. The next highest would be this one. Again, it is more, has more deviations. It's a little bit more spread out than this data set. So they each have values directly correlating to their mean, but again, this one is just a tad bit more spread out. So this one would have kind of like a medium standard deviation, and then again, this one would be the lowest. All right, so hey, we're gonna just do this a couple more times for some different data sets. Let me go back to this web page. Okay, so I just got this from Khan Academy. It's ranking standard deviations from the largest to the smallest. Okay, so if we were looking at this data set, which one appears to have the highest standard deviation? Which one appears, like in other words, which one appears to be the most spread out? Which one has the highest standard deviation? And I think it's pretty obvious that it's this. The next highest standard deviation would be certainly this one. It's more spread out than this on the bottom. The bottom would definitely have the smallest standard deviation because it only has 2 points that don't fall on its mean. So I'll hit check. Maybe you guys can try to think of this one on your own as well. It's a little bit more difficult. So which one is the most spread out? It looks like this is. It has the fewest observations next to the mean. It's more spread out than this one, certainly. This one would have the smallest standard deviation because it doesn't have any of these like outliers way out here, right? It doesn't have a 0 or 100. So I think this is looking pretty good. I can post a link to this on my Schoology page if you want to practice on your own, but that's going to do it for this video. Thanks for watching, guys. See you in class. Bye.